A very good morning to one and all. Respected CD Sir, Dr. Shishidhar Muniyappa, SVGA Bengaluru, Principal Dr. Suresh Sir, Sri Venkateswara College of Engineering Bengaluru, Dr. L.M. Patnaik Sir, Adjunct Professor and INSA Senior Scientist, NIAS Department of Electronic System Design, IISc Bengaluru, Dr. Shivashankar, Professor and Head, Department of Electronics and Communication Engineering, SVCE Bengaluru. Respected participant, learned delegates from corporate and academia, a very good morning to one and all. I am Ravi Gatti, Assistant Professor, Department of Electronics and Communication Engineering, feels privileged to extend a warm welcome to all for the third phase of the AICT short-term training program under AQIS program on Data Science for 5G Cellular Networks from 3rd to 8th August 2020. We have successfully completed the first 2 weeks of the AICT sponsored short-term training program under AQIS program on optimization techniques for 5G cellular networks and compressive sensing techniques for 5G cellular networks using MATLAB, with 22 technical sessions were delivered by eminent personalities with more than 5,000 views on our broadcast YouTube channel STTP ECE SVCE. On this occasion, we thank AICT for sponsoring, motivating to host this event. We would like to thank to management and principal of Sri Venkateswara College of Engineering for this constant support and encouragement for conducting this STTP. For today's Elite event, I would like to welcome our beloved CD Sir, Dr. Shishidhar Muniyappa, SVGA Bengaluru, for this Elite event. Because of Sir's busy schedule, Sir could not join for the session. However, conveyed his best wishes for the program. I would like to welcome keynote speaker of the today's session, Dr. L.M. Patnaik Sir, Adjunct Professor, INSA Senior Scientist, NIAS, Department of Electronic System Design, IISc Bengaluru, for this event. On behalf of management, principal and head of the Department of Electronics and Communication Engineering, we welcome you, sir, for this event. I would like to welcome our beloved Principal Dr. Suresha, Principal SVCE Bengaluru, for this Elite event. The building of this event is not happened in a single glance. Enormous effort of the team, extensive support from the elders, and fabulous synchronization by our beloved Head of the Department of ENCE, Dr. Shivashankar Sir. I would like to welcome Dr. Shivashankar Sir for this Elite event. I am privileged to welcome all the participants for this event. Dear all, now we will begin the technical session 1 by Dr. L.M. Patnaik Sir, Adjunct Professor, INSA Senior Scientist, NIAS, Department of Electronic System Design, IISc Bengaluru. I would like to introduce Sir to our esteemed audience with a brief profile. Professor L.M. Patnaik obtained his PhD in 1978 in the area of real-time system, D.Sc. in 1989 in the areas of computer system and architecture, both from the Indian Institute of Science, Bengaluru. During March 2008 to August 2011, he was a Vice Chancellor, Defence Institute of Advanced Technology, Deemed University, Pune. Currently, he is an Honorary Professor with the Department of Electronic System Engineering, Indian Institute of Science, Bengaluru, and INSA Senior Scientist and Adjunct Professor in the National Institute of Advanced Studies, Bengaluru. Prior to this, he was a professor in the Department of Computer Science and Automation at the Indian Institute of Science, Bengaluru. During the last 50 years of his long service, his teaching, research and development interests have been in the areas of parallel and distributed computing, computer architecture, CAD for VLSI system, high performance computing, mobile computing, theoretical computer science, real-time system, soft computing and computational neuroscience, including machine cognition. In these areas, he has 1,286 publications in referred international journals and referred international conference proceedings, including 30 technical reports, 43 books, 26 chapters in books. He has supervised over 30 doctoral theses and over 160 master theses in the above areas. In the areas of parallel and distributed computing and soft computing, he has been a principal investigator for a large number of government-sponsored research projects and a consultant for few industries. One of his research papers in the area of adaptive genetic algorithm has been cited over 3,400 times, a survey article on genetic algorithm over 2,200 times by Google Scholar with an I-10 index of 134. He had served as a president of Advanced Computing and Communication Society and a Computational Intelligence Society of India. He is a distinguished lecturer of the IEEE Region 10. He is a distinguished visitor of IEEE Computer Society for the Asia Pacific region. As a recognition of his contribution in the areas of electronics, informatics, telematics, and automation, he was awarded Dr. Vikram Sarabhai Research Award in 1989, the Honorable Mention Award 4th CSI IEEE International Symposium on VLSI Design in 1992, Dr. Ramlal Wadhwa Award for the year 1992 by the Institute of Electronics and Telecommunication Engineers for his contribution during the last 10 years in the field of electronics and communications. The Platinum Jubilee Lecture Award, Indian Science Congress in 1994, the Samantha Chandrasekhar Award for the year 1994 by the Orissa Science Academy, the Certificate of Appreciation for Excellent Service and Dedication to the Objectives of IEEE Computer Society as a distinguished visitor in 1995, the Vasvik Award in the field of computer science and Technology, the Distinguished Professional Engineering Award by the Computer Engineer Division of the Institute of Engineers in 1999, the IEEE Computer Society, the 1999 Technical Achievement Award for his contribution in the field of parallel, distributed, and soft computing and high-performance genetic algorithm. The fourth Sir C.V. Raman Memorial Lecture Award in 2000, the first SVC IA Memorial Trust Award for Telecommunication Education, the Institute of Electronics and Telecommunication Engineering Pune Center in 2000, the Pandit Jawahar Nehru Award for Engineering and Technology in 1999, the Om Prakash Bhasin Award for contribution in the areas of electronics and information technology for the year 2001, the FICCI Award for Innovation in Material Science, Applied Research and Space Science during 2001-2002, the IEEE Computer Society's Meritorious Service Award in 2002, the Alumni Award for Excellence in Research for Engineers, the Indian Institute of Science in 2003, Distinguished Engineer Award for the Institute of Engineers in 2004, Goyal Prize for Applied Science in 2005, Honorary Fellow, the Indian Society for Technical Education in 2006, Indian Science Congress Association Srinivasa Ramanujan Birth Ceremony Award in 2007-8, Biju Patnaik Award for Excellence in Science 2007. In the year 2009, the Top Management Consortium Pune Education Defense Service Excellence Award in 2009 during March 2010, Distinguished Alumnus Award 2012, National Institute of Technology Roorkela, Felicitation of International Neural Network Society India Chapter for Outstanding Contribution to Soft Computing, December 2014, M.N. Saha Memorial Award for Best Application Oriented Paper by IETE in 2016, and Lifetime Achievement Award, Computer Society of India 2017. He is a fellow of IEEE and the World Academy of Science, State, Italy, the Computer Society of India, Indian National Science Academy, Indian Academy of Science, National Academy of Science, and Indian National Academy of Engineering. He is a life member of VLSI Society of India and Instrument Society of India, a founder of member of Executive Committee of Association for the Advancement of Fault-Tolerant and Autonomous System, a fellow of the Institute of Electronics and Telecommunication Engineering and the Institute of Engineers. His name appears in Asia's Who's Who of Men and Women for Achievement, Directory of Distinguished Computer Professionals of India. For over 150 international conferences, he has served as a general chair or program chair or steering committee chair, most of them sponsored by IEEE. He has been delivered over 300 keynote invited talks at several international conferences covering a broad range of topics in computer science and engineering and IT. He served on several significant committees for leading professional societies such as IEEE, CSI, IETE, and Institute of Engineers, review and policy committees for government agencies such as DST, DBT, MHRD, CSIR, DOS, UGC, AICT, DRDO, DIT, and UPSC, including on the Yashpal Committee to advise on renovation and rejuvenation of higher education. His participation in the reviews of several engineering colleges in the states of Karnataka, Kerala, Andhra Pradesh, and Maharashtra, organized by AICT, UGC, NBA, and TechUp, has significantly improved the quality of technical education in the country. As Vice Chancellor of the Defense Institute of Advanced Technology deemed university, he was responsible for conducting large number of doctoral, masters, short and long-term courses in the field of defense technologies for service officers from the Army, Air Force, Navy, DRDO scientists, officers from Indian Ordnance Factories and Directors General of Quality Assurance and service officers from several friendly foreign countries. He had initiated few new postdoctorate programs for relevance to defense services, including one on cybersecurity, a new center on nanotechnology for defense applications, and a collaborative program with the Naval Postgraduate School, California, USA. He has delivered several invited talks in USA, Canada, France, UK, Yugoslovakia, Hungary, Switzerland, Australia, New Zealand, Hong Kong, Singapore, Malaysia, Sri Lanka, and Japan. It needs to be emphasized that his training as well as the research work done by him are entirely indigenous based. His contribution to Indian higher education system are outstanding. We are greatly honored and privileged to have you with us, sir, for this elite event. With this introduction, I once again welcome sir and request sir to take over the session. Please, sir. Sir? Sir?
Hello.
Yes, sir. We can hear you.
Are you able to hear me?
Yes, sir.
You can hear me. What is
Yes, sir.
your
We can
name?
hear
You
you.
said.
Ravi, sir.
Hello. I'm asking you, Ravi, Professor Ravi. Okay. Okay. Nice, embarrassing introduction. I would
Thank you.
like to thank the principal, Professor Suresha, and your HAD, Professor Shivshankar, and Professor Rajendra, others, and the management for having invited me to be here this morning. Is it clear? Is it audible?
Yes, sir. It's audible, sir.
Okay, fine. Yeah, one of you should keep the mic on for maybe for interaction like this. Any problems?
Sure, sir.
Uh,
Sure.
in fact, I had requested that you did not go through such an elaborate introduction. You can visit my website
Ah, sir.
www.lmpatnaik.in, which of course is not updated. So that has my Gmail email address. Any interactions, anything you want to do after the talk, you are most welcome introducing the meeting here. So what I have tried to sort of put together, and I am planning during the next 1.5 to 2 hours, is a quick overview of big data, AI, machine learning. Last time I gave a talk few days ago on IoT, Internet of Things. I said IoT generates huge amount of data. The projection is we may get billions and billions of data over the next few years, whether it is sensors, whether it is
Sorry for the inconvenience. So because of some network issues, sir has been exited from this meeting. Sir will join soon. Kindly bear with us because of some network issues. Sir will join the session soon. Just for the reminder for the today's afternoon session, uh, we have one more technical talk which will be given by Professor Mahavir Panna, Assistant Professor, Department of Electronics and Communication Engineering, SVC Bengaluru, on Introduction to Data Science. So I request all the participants kindly join for the afternoon session also. We request all the participants kindly subscribe our YouTube channel so that you will get and click on the bell icon so that you will get a notification before the session starts.
Like
Hello.
Yes, sir.
So I need to
Share the screen, sir.
Is it okay? Does it come?
Yes, sir.
Okay.
Full screen it, sir. It's visible, sir, now.
Is it okay?
Yes, sir.
Okay. So from where it got snapped? From the beginning I should start?
Yes, sir. You can start from the beginning, sir.
Okay, fine.
Thank you, sir.
Yeah. That said, thank you everybody uh, for inviting me to be here this morning. As I was telling, I wanted the introduction to be very brief, but it tended to be very long. So you can visit my website. There you have what is called my Gmail address. If there are any specific queries, questions, you can pose them. Okay, you can interact with them. At the end, also, we can discuss. But if you want to have further discussions, you are most welcome. Okay, contact me or fix up a time, visit me in the institute or NIAS. There is no problem. Uh, Last time I gave a talk on IoT. Is it clear now? Hello? Hello? Last time I gave a talk on IoT. Hello?
Yes, sir, it is clear, sir. Continue,
Clear,
sir.
yeah. Yeah. If there is any problem, you immediately keep calling me on the phone. Okay?
Sure,
Yes.
sir. Sure, sir.
Yeah. Uh, See, when we were discussing last time, I talked to you about IoT. I did mention to you that whether it is a healthcare application or agriculture application or smart city application, we generate huge amount of data from these applications. Okay. In a big data environment, data essentially is collected one from IoT. We said in the future we may have billions of these sensors, maybe about 20 billion, 30 billion, 40 billion. There are all sorts of projections. Cisco has something, there are other companies have some projections. Last time I told it during my talk, each one of us will be connected to something like 6 to 7 probably sensors and sensing elements surrounding us. So when we have so many of these sensors generating data, that too heterogeneous with different standards, the data has to be stored in a database somewhere, right? And other than the data generated from sensors, data is also generated from Facebook, from Twitter, some of these sources. All this data is not structured. By structured, I mean if you look at a typical database in an organization like a college for students, marks, courses, faculty, courses, salary deducted, salary earned, they are all characters, names, and numbers. It is very simple and easy, straightforward to use standard packages. You have Oracle and large number of them, database packages. You can store this data, retrieve this data using what is called a query language. For example, structured query language. If I want to give a query, tell me the names of all students who have secured distinction and they're from the EC department and female students. So if you want to give such a query, it has to be processed in the database. There are special purpose query languages which you select from where type of clauses called SQL. So the challenge when really lies when you are handling voice, images, pictures. Okay, these are unstructured data. So in a big database environment, we talk about structured, by that I mean text and numbers. Unstructured is images, pictures, voice, and semi-structured, that's something like XML markup language. And you have emails where it is from to some structure like this, the body differs. So it is a different type of data. And sensors are also heterogeneous. We get diverse amount of data from all these sources. Last time I told you during IoT, when you have heterogeneity, you have problems of standards. So this data has to be stored somewhere. Normally, we store the data in a cloud platform. It can be private cloud or public cloud. When you have the cloud, you have to maintain security, right? So simply data staring at you is of no use. You should use this data, take some decision, come to some conclusions. How do you do that? We use some AI algorithms, classification algorithms, machine learning algorithms to classify. For example, I have an image stored about an aircraft. I want to know whether it is an enemy aircraft or friendly aircraft. Okay. So some decisions have to be taken to take some actions eventually, right? So the problem is, as I said, the source of the data is many. They have to be stored in a cloud. And last time I talked to you about edge or fog computing, where you have the sensors at the boundary, at the sensor level itself. You do some local processing using fog computing or edge computing because it will be faster. But then it won't have much memory. So where you need huge amount of data, it has to be pumped into the cloud. Cloud may store the learning algorithms and AI algorithms and all. That is why IoT, big data, data science, analytics, AI, machine learning, they're all very intimately connected. One depends on the other one. Last time we were talking about 5G cellular networks. Okay. Even in 5G cellular networks also, there are issues of use of AI and machine learning to come up with some decisions. Okay. So what I will do, I will try to give a very quick overview. I will not get into technical details because I understand we have too many talks also following my talk, those who are going to talk about details. And I will introduce the terminology as synthesizing overview because getting into the all aspects of the details maybe it's like a 2 semester courses. Okay, when you talk about big data, databases, and all that thing. And fortunately, when you talk about big data and machine learning, a lot of this software is available free, public domain. You can download. For big data, we have something like Hadoop. You can download that and play with it. We have many types of databases, we say Hive, MongoDB, Cassandra, many of them. You can essentially download and play with it. There is a programming language now picking up called R, okay, which was developed by some professors who were teaching social science in New Zealand. It is good for graphics, good for storing data, okay, and this is used extensively in big data, AI, and some of these computational type of application decision makes, right? And luckily, this is also something free. You can download. There is a user group. So much of it is available in the public domain. So when I said increasing data, from where do you get data? From the mobile sensors. We are moving, there are many sensors. There we have on our body, there are sensors. Last time I talked to you when you are jogging, there is something like a watch. Okay, it gives you at what rate I am watching, my the heart rate and all those things. It is stored in a cloud, it generates some data about the individual. So there are so many people jogging in the morning, so you can see the amount of data it is generated for one specific operation from social media like Facebook and all, video surveillance, malls, apartments, okay, institutions, colleges, airports. These are all images, different type of data. Video rendering when you try to manipulate with those things. Smart grids in electrical power systems, okay, where you have smart meters, you have energy generated from wind, thermal, hydel, different type of sources, how they are connected in a grid, distributed, what is the optimal way of using. Then medical imaging. Like there are so many patients. You talk about CT, you talk about X-ray, you talk about PET, you talk about SPECT, MRI. Particularly now in the days of pandemic and COVID, you talk about so many patients. Okay, we have X-ray images, we have CT, MRI, PET, different type of things. And people, those who have comorbidities, suppose they are cancer patients, they are cardiac patients, they have other different types of data generated, ECG and other things. Okay, and when the patient is under treatment, you want to store information about how the treatment is going on and whether there is a ventilator, what is the setting of the ventilator, and all this data has to be analyzed to come to some conclusions. And if you are putting an AI machine learning algorithm, it has to automatically learn these things. For example, in a COVID scenario, when there are hundreds and thousands of patients. You can't expect an expert doctor to be sitting or standing by the side of every patient to look at the setting of the ventilator. Because when you talk about ventilator setting, it is a challenging problem because there is a natural flow and this is something pumped externally. They have to synchronize, otherwise it will be dangerous. So there is a control algorithm. Different patients need different conditions based on their health condition. So this has to be stored for later use. The data can be always very nicely used for coming to some decision. This is using machine learning or AI technique, right? So data creation is occurring at a record rate referred to herein is big data and has emerged as a widely recognized trend. This continues to increase in the volume, so much data we are getting, and detail of data captured by which one? Social media, as I said, Internet of Things, IoT, sensors, and multimedia, and produced an overwhelming flow of data. Big data is initially being attention from academia, government, industry, all of them. You can see Facebook, then the 30 plus petabytes of data. Okay, LinkedIn, Amazon, okay, Akamai, many of them. And if you look at some of the newspaper, New York Times, when they talk about into 11 million finished PDFs in 24 hours, that is 4 terabytes worth of raw images they essentially talk about. Newspapers, news media, the data is generated from different sources. Okay, we are essentially living in this environment. Okay, the data is staring at you. You have no time to look at that. You can't look at graphs. You can't look at tables. You can't look at images. It has to be processed using some intelligent algorithms, AI machine learning algorithms, and it should come to some conclusions. Okay, that is where we talk about. There is, you see, Hadoop. It is a platform for a facility for using big data. It is again, if you look at the file system, what is supported here, it is available public domain free in a big data. Okay, one can get it. What happens in this case is the data is distributed on the different clusters, servers, okay, at different places. It is a large distributed system. So how the data is generated, gathered from them, processed, right? And you find that there is a the elephant symbol there. Hadoop is not acronym for something. It is named after the toy elephant of the inventor of the package. When we talk about big data, it has three important things. Volume, data are numerous. Okay, data cannot be categorized into regular relational databases. In relational databases, what happens? We have a key, like if it is a student, student ID number in that university or the college. Okay, so we store in a row ID number, name, gender, age, then department. Okay, then you will store what subjects are taken. Okay, all then some marks and all that thing. It is in a flat table type of structure, what is called relational databases. But unfortunately, when you talk about images, voice, and all that, you cannot do like this. So it is a variety of data, as I told you. Data are generated, captured, and processed rapidly. Real time, non real time, many applications, we have no control from diverse sources. That is why we talk about three V's in big data: volume, velocity, variety. People have added other thing called veracity, another V. Somebody has added value because data has value now, okay, for everything. Uh, So you talk about what is called many other types of V's also. What is the challenge? The nature of big data is indistinct, it is not clear, and involves considerable process to identify, translate into new insights you should get, conclusions. A major challenge for researchers and practitioners if this growth rate exceeds the design appropriate platforms for data analysis. Okay, it is so challenging. You should develop right type of platforms. Big data classification, if you see, as I told you at the extreme left, you get from the web and the social networks, you get from IoT, you get from sensors, different sources, right? The content is it is structured like numbers, characters. It is semi-structured like what I told you, some XML markup language, emails and all, unstructured. like what you get in a Facebook, Twitter, and all that thing, images, voice. It has no structure. It doesn't comply with anything standard. Data stores. How do you store? You can have a key value. Like we talk about a student, there is an ID, there is a key value. The employee in a college or an organization, there is an ID or key value. If you give that which is unique that person, by that you can retrieve the entire information about that person. Okay, name, income tax deducted, salary, leave taken, all that thing. Right? It can be document oriented. It can be stored something like a document. We will see that it can be stored in a straight column. That is what is done in some mode of big data now. It is a graph based. In a graph, as you know, there are nodes, there are edges. Node will store some information. For example, node will correspond to a department. Edges will correspond to the faculty members. A department has so many faculty members. Okay. At the topmost level, node can be a college. Under that, there may be different edges departments. Again, at the end of that, there will be another node in the department. There will be so many students and all that. So you can have a node and edges representing some information. The edges are the links connecting one node to another node, so conveying some information. So it can be stored in a graph. There are different methods. Data staging, there are different operations. We will talk about that called cleaning, normalization, transforming. So what you do in a transformation, you transform so that it is ready to be used in some format. In cleaning, you take out some redundancies, some errors, and other things, make it clean. In normalization, what we do, we avoid some redundancies. You know, there are some repetitions and redundancies in huge amount of data. When we store, we are storing in a table or any mechanism, okay, or any storage media. You try to avoid the duplication or the redundancies. Data processing, you know, it can be in a batch mode in a computer. You give that and it processes, give you the result, or in real time or interactive, you can just interact with that in a time sharing mode. The data sources, as I showed you, web or social, IoT, sensing. Social media is the source of information generated via URL to share or exchange information and ideas in virtual communities and networks such as blogs, microblogs, Facebook, Twitter, and all that thing. IoT represents a set of objects. What are those objects? Smartphones, digital cameras, tablets. They also generate huge amount of data. When these devices connect with one another over the internet, they enable more smart processes and services that support basic economic, environmental, and health needs. Okay. As I said, the sources are many. Today, you talk about in this country Aadhaar. Aadhaar data is so much. It captures so much of information. And this is not a structure. They take fingerprint from you. They take iris information data from you. Okay. Other than that, there are numbers, phone numbers, this, that, and other types of information. And for so many people of the country. So this is used by multiple people, stored somewhere, okay, and it is accessed. Of course, there are some security concerns and all that thing. Accessed for different purposes. Several sensing devices exist to measure physical quantities, change of them into signals. What are these sensors? They would be temperature, pressure, humidity, flow, right? All these variables. If you are talking about a smart city, it could be carbon CO emission. If it's a pollution control, if it's a traffic congestion, images. If we are talking about agriculture application, it can be water level in a field, it can be moisture content in a field. Okay, if it is reservoir water level somewhere, there are different types of measurements conducted and performed. As I said, structured data are often managed by structured query language (SQL), a programming language created for managing and querying data in relational database management system. In relational database management system, data is stored in a flat table or a relation. What are the examples of structured data? Numbers, words, dates. These are simple, okay, to store, not much of headache, what we find in any organization to do something, whether inventory of parts, salary of people, marks of students, anything. Semi structured are data that do not follow a conventional database. They may be in a form of structured data that are not organized in relational database. Examples: emails, XML markup language. Unstructured, such as text messages, what you send, location information, videos, so many videos as one generates and keep transferring. Social media data are all data that do not follow a specified format. Considering that the size of this type of data continues to increase through the use of smartphones, the need to analyze and understand such data has become a challenge. More and more of unstructured data is coming. So how do you store that? As I said, key value, giving an ID is an alternative relational database system that stores and accesses data designed to scale to a very large size. You use a key, an ID. An example is Hive in big data or data science. We talk about the database which supports that. Then a column oriented database stores its contents in columns aside from rows with attribute values belonging to the same column. There is one type of database called MongoDB HBase, which stores data simply column after column you store. Don't bother, like name, place living, latitude, longitude, nickname, all sorts of things. I told you graph base. There is one database called Neo4j in the big data, is designed to store and represent data in a graph with nodes, edges, properties related to another through relations, I told you. Okay. Big data, and as I said, it involves some operations: cleaning, transforming, normalization. What is cleaning? It is the process of identifying incomplete and unreasonable data. Some data may not be complete, it may not be reasonable. We have to identify, clean that, and take this action. Then only store. Transform is the process of transforming data into a form suitable for analysis. When you want to do analysis, it has to be in some form, some format, some structure. We will have to transform to that. Normalization is the method of structuring database schema to minimize redundancy. You do not want to have the repetitions. Like if you are storing in a table every time, you need not store some information about the name of the college, name of the department. If certain number of students, large number of students are belonging, you create a relation. You see that some of these things are avoided. Properly design these things so that duplication is avoided, so that you save on the storage space. What are the platforms for big data? What do you need? One of the things, you need a cloud, because huge amount of data has to be stored. Nobody stores this data in local storage, in local disk, even though access is fast. These days cloud is pay for everything, right? Platform as a service, okay, software as a service. Similarly, if you want storage, how much terabytes, you for that much you pay. For how many days you store the data and access that. Somebody has to take care of the security. If you want to have in the local cloud, like in a college, many of them want to share their thing, you can a local cloud and share that. Each department doesn't have to store that thing, or each laboratory doesn't have to do that thing. You need a parallel computing environment. As I said, huge amount of data. You have to process them. You have to get the results fast, come to conclusions, classification, and all that thing. I cannot wait for hours together. So I need to use parallel distributed computing. The advantage of parallel distributed computing is you do operations in parallel, split, so that all the processes, clusters, they do in parallel. You get results very fast when you want to search. For example, you go to a shopping mall, you pay, you go to Reliance or Big Bazaar, you give your credit card. Somebody says, does something to swipe and all, authenticate whether your credit card is valid or not. So, what is it? There is a number. And this is done not in days together, it is done in few milliseconds or seconds. What happens? The information goes to a server somewhere, use this one. They have stored all the valid numbers. Maybe in parallelly the search is going on. The server may be in New Zealand, or maybe in Bombay, maybe in Canberra. We have no idea. Okay, it goes there, it searches, or maybe Singapore. It comes up with some result, right? So these are all have to be done in parallel when you talk about big data, data science, because you are searching through huge amount of data. For that, we use a platform called Hadoop, which is called, as I said, it is named after the toy elephant of the inventor of the person who has developed that. We have a general purpose programming. You can use for programming Python, SAS, any of these languages. And SQL was a standard database in relational databases. Now we use what you call not only SQL. This is a standard term because SQL is good for applications where it is a relational database, where you can say select from such and such relation where such and such condition is satisfied. Okay, it is easy. But here it is not so. We cannot use that type of constructs. That is where we are using MongoDB, HBase, Neo4j, some of these database packages. And luckily, most of them are available free at the public domain, Hadoop and some of these packages. Okay, data visualization. I said huge amount of data. Who has time to look at the tables running into volumes and volumes of books? Okay, you need visualization, graphical methods, 2D, 3D representation. There is a package called Tableau. One can use that. Machine learning is the important thing because you have huge amount of data. You have to use supervised, unsupervised, reinforced, some of these machine learning or AI techniques to get to some conclusion, some classification. Because from this data, it has to learn something and take right decisions when it encounters a future decision making the stage, right? So this package is called Mahout. Luckily, if you see who is important for an elephant, a Mahout is important for an elephant because Mahout is the one who controls. Similarly, the a big data and all that thing, the important component is the machine learning package, Mahout. So most of these things you can get simply free. What is Hadoop? As I said, it is created by Doe Cutting and Mike Carafala in 2005. Cutting named the program after his son's toy elephant. Framework for running applications and a large cluster of commodity hardware. This large cluster of hardware, they are distributed at different places. That is where we say we have HDFS, okay, that is distributed filing system. Scale. Petabytes of data on thousands of nodes in a Hadoop ecosystem. Processing logic or code travels throughout the cluster and not the data. It is the code which goes from place to place, not the data. Okay. This is a typical architecture. I will not get into the nitty gritty details of computer science. What happens in HDFC architecture? There is something called a name node, keeps track of the file metadata. That means which file is there in the system, where those file is stored, whether it is stored in SVC, whether it is stored in UVC, whether it is stored in IIT Bombay, or it is in California Berkeley University. Okay, where the files are stored. Okay, in the name node metadata operations, that is name and the details, which files are in the system and how each file is broken down into blocks. Data nodes provide backup store of the blocks and constantly report to the name node to keep the metadata current. So now what happens is after the name node comes, you have what are called the data nodes. Okay, those are the ones which store the data. And we talk about what are called different blocks within that data is stored. There are client server mode of this one, you write operations, and we have a replication essentially to take care of some faults, redundancy, and all that thing, right? So the name node is connected to the data node because the name node has to know where the data is stored, which data is stored somewhere, so that when a query is posed, it has to go to the right data node to fetch that data. There is one important operations you will get in big data, data science, Hadoop, which is called map reduce. You will get it standard. Okay, it is a standard term you will be introduced. So, how to distribute the computation? Because the computation is done at different places. Distributed or parallel programming is very hard, you know. It is communication at different places. You have to essentially, the code traversing, the processing happening, and put the results back. MapReduce addresses all of the above. It started from Google's computational data manipulation model. Google started with this thing. It is an elegant way of work with big data. You have a CPU, memory, and disk, the entire thing. Then doing processing, getting the data from that. Okay. What we find in a big data is a cluster architecture. You have 1 gigabit per second between any pair of nodes in a rack. You can see one block, one rack, CPU, memory, disk is one, CPU, memory, disk is one. There is a switch connected to that, linking to all those things. Each rack contains 16 to 64 nodes. Okay. And 2011, it was guesstimated that Google had 1 million machines of this type. So you have a large number of them. You can connect a hierarchy. Okay, there is one level of switch is like a tree structure. Then it goes. So at one level, you talk about 1 gigabits between any pair of nodes, and the top level we talk about 2 to 10 gigabits backbone between the racks. The computations are performed in this. So what are the ideas and issues here? Copying the data over a network takes time. Bring computation close to the data. Where data is there, you bring the code there, as I said. Store files multiple times for reliability. MapReduce addresses these problems. Google's computational data manipulation model, it is an elegant way to work with big data. What is the storage infrastructure you will need? Typically a file system. Okay, like Google uses Google file system, Hadoop uses HDFS, and in fact these days people have gone beyond Hadoop, which is called Spark, where the data is resident in the memory itself, in memory resident data, which is very fast. And the programming model here is called MapReduce. I will not get into too much details of the programs and all. Give an overview. Sequentially reads a lot of data. What map did? Extract something if you care about. To satisfy a condition, you want some data. Map will extract that, which is grouped by key. You will have a key. Okay, satisfy the data satisfying some condition. Reduce will what it will do? Aggregate, put together, summarize, okay, filter or transform. Then write the result. Okay. So outline stays the same, map and reduce change to fit the problem. So this is what you can see. I have shown different operations here. See, initially we have what are called input key value pairs. Each of these things, there is a key, there is a value. Okay. Value means it is something like a number. Okay. So attached with that, we give a key which satisfies some condition. Okay. Some designated key to that. We identify, we designate them by key value pairs. So what the map does, intermediate key value pairs, okay, it all at the different stage, we will show with an example. It puts together the key value, all of them, the putting together. Then once you get the intervalue key value group by key, then you take the same key, what are all the values you put together. You take the next key, what are all the values. Next key, values. Then reduce means you essentially sum and find out what is you aggregate them, as I said, the reduce output key value pairs. For example, in this case, you see is simply word counting. There is a big sentence there. The crew of the Space Shuttle Endeavour recently returned to Earth as ambassadors. Okay, something like harbingers of a new era of space. Blah 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 blah. Okay, so what it does in the map, read the input, produce a set of key value pairs. When it reads, first line it reads, it says the key value, that is the, and it is 1. Okay. Similarly, we have again in the same line what a crew, it is ones. Of 1, the 1, space 1. Goes to the next line. Shuttle 1. Again, sorry, space 1. Shuttle 1. Okay. Endeavor 1. Like you have a key, but the key is like the crew and all that thing, value. Okay, the number attached with that. Group by key value. So now what I'm doing, I'm putting together all like crew one in the entire passage what I've looked at, then space one, D1, 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 then subtle one, recent one, like that. Then in reduce, what you do, as I said, you put together everything, you aggregate. Okay, how many crew are there? Crew two. Okay, crew once again, crew two. Then space one. D. How many times aggregate if I do? Three, as you can see. Then subtle ones, recent ones. So this is all obtained from different places. What you want to do, satisfying the condition, what operation you want to do. So there is a key value designation, aggregation, do this operation. Okay. So this is what precisely is essentially done in a map reduce operation. We have what is called the Hive database. It is a system for querying and managing structured data built on the top of MapReduce and Hadoop. It is suitable for structured logs with very rich data types like lists, maps, and all. You can query that, get information. A user base wanting to access this data in the language of their choice. Why? Because when data is stored, you want to access the data satisfying some condition. Okay, I told you, you want to get some information, how many students have passed in distinction, or how many faculty members have completed their PhD and they have seniority of more than 3 years for some specific promotion or assessment, whatever it may be. So you want to access this file satisfying this condition. A lot of traditional SQL workloads on this data, filter, joins, aggregations, and all. What are the challenges in big data? Representing the data, as I said, there are diverse types, variety is different. Redundancy reduction and data, like there is a repetition, duplication, and you will have to data compression. You have to compress the data. And scalability. When the nodes are large, the data is large, the sources are large. How do you handle this thing? Availability. That when there are failures, nodes fail, fault tolerance. How do you take care of that? And we have stored data somewhere. The disk, okay, because of that crashes. How do you get the data? We talk about redundant array of this one, RAID architecture. Okay. So there are different type of architectures you have to handle. There may be communication problem, communication failure, link failure. Okay, how do you handle this availability issue? Privacy. Okay, privacy is one, security is one. Okay, if you are talking about something like medical database, your health parameter, health statistics, data is stored on cloud. It has to be accessible only to your doctor and yourself. It has to be properly encrypted, stored that. We are talking about Aadhaar data. Aadhaar data has something about us. You know, recently there was some problem of hacking. Aadhaar data was accessed by people. Okay. So when you talk about that, there is a privacy issue. Somebody should not access this, whether it is local or global cloud. Local cloud, there is not much of problem. In a global cloud, the problem is very serious. Privacy, security. The data has to be secure. Transformation. As I said, you should be able to transform it so that it can be used in proper form to do some operations. Okay. Raw data you collect in a different form, that is totally different. But for it to be used for processing, it has to be transformed. Scalability is the ability of storage to handle increasing amount of data in appropriate manner because it is increasing continuously. Cloud computing lacks features to support relational database management. This drawback is resulted in the popularity. That is why we talk about not only SQL. SQL is used in the context of relational database management traditionally. A NoSQL database provides the mechanism to store and retrieve large volumes of distributed data. The features of this are in a traditional database, we talk about first what is called a schema to design the database. There is nothing like that. You can easily replicate, easy replication support, simple application program interface, consistent and flexible nodes. I told you different NoSQL databases are available. Few are commercial, quite a bit of them are public domain, free. You can download, play with that. We have key value. This is based on a key value. I told you when it's a student database, there is a student ID number, the college or the university gives. It is a faculty ID. There are packages like Amazon, DynamoDB, Oracle 11G. Oracle, this one is commercial, you will have to pay. Then Redis, graph-based DBS, Neo4j, infinite graph, Sonnet, column-oriented. Column after column you can store, HBase, React, Cassandra. You can store like a document, CouchDB, MongoDB, and all that stuff. Okay. What are the features of not only SQL database? They are general purpose, rich data model, full featured indexes, and we have a good query language to get the data. Very easy to use, easy mapping to object-oriented node. They're fast and scalable. You can scale them. Okay. I told you specific data which is column oriented. You can show that the name is Will, his eyes are blue, birthplace is New York, his alias names are Bill and Lasiaco, location, okay, latitude, longitude is given, boss is Ben. You store column after column there. Traditional relational database fact table doesn't allow you to do that. MongoDB does not need any predefined data schema. Every data is stored in the form of a document. It has to be simple. What are the challenges in big data? It's a transformation. Transforming data into a form suitable for analysis is an obstacle in the adoption of big data. In the case of structured data, the data is pre-processed before they are stored in relational database to meet the constraints of schema on write. However, in unstructured, the data has to be first stored in distributed databases. What is the example in big data? HBase, before they are processed for analysis. Unstructured data are retrieved from distributed databases using some schema on read constraint. HBase is a distributed column-oriented data store, as I told you. This is an Apache open source project whose goal is to provide storage of the Hadoop distributed computing. Data is logically organized into tables, rows, and columns. And this is how it is stored. I will not get into the details of the technicalities. Tables, it is organized in form of a table, one can store column family and all. Okay. Privacy concerns continue to hamper users who outsource their private data into the cloud storage for analysis. Most people, most organizations, like when you have electronic health records, medical applications, and all, they outsource the data to an agency who maintain the cloud. You pay for the storage of the data, network facilities, and all in cloud, as you know, you pay as you use. So that is where you get into problems of privacy. Is somebody hacking? Is somebody stealing your data, misusing your personal data, and all that thing, like Aadhaar data misused and all. Okay. So this is an important concern. This concern has become serious with the development of big data mining and analytics, which require personal information to produce relevant results such as personalized location-based services. So currently, what is done is encryption, coding. Okay, you encrypt the data. Y is Z of X. X refers to the plain text what you have. Y is a cryptogram. Okay, and Z is the secret key. You take a key, encrypt with that key, and you know there are public key, private key, so many encryption techniques and all. One has to use it. But then the moment you use wireless medium, we have to be very careful because wireless computing or wireless medium is highly unsecure. One has to be very careful. Hacking is very easy. There are machine learning algorithms in data science used. As I said, machine learning algorithms are largely used to predict, classify, or cluster, group the data, classify into different things like faces, images, objects, and all. Okay, and you want to predict also what happens in future. In general, machine learning algorithms that are the basis of AI, they are used for image recognition, speech recognition, recommendation systems, systems ranking, and personalization. This one. Recommendation systems are like, see, if you were buying a product, or suppose if you are watching a movie, okay, or if you are watching some listening to some songs, there are different people do that, right? For example, if you take the scenario of your Kannada movies where you talk about there are semi many. You have like you have movie like Oh, you have movie like Mungaru Bale, you have movies like Brahmachari, okay? You have many like French biryani in Hindi. You talk about Three Idiots, okay? There are, or you talk about Mughal Azam, okay? You talk about Munafai, MBBS. There are different types of movies. People have different interests depending on comedy, romance, thrill, or action movies, okay? And different types of movies. So, what a recommendation system does is when there are so many people, you might have watched a specific movie, okay, you rank it with some ranking number. Your friend might have watched some other movie which you might not have watched. So, what the recommendation system does is by looking at all these movies and their rankings, if you have not watched a movie and your interest matches with that of somebody else, it will recommend you that your interest is watching comedy movies. You have watched such and such movie. Your friend who has a similar type of interest, he has watched this, you do that. It can be used for products in Amazon, for Spotify, for music and all that thing. It can be in anything. Okay. So what happens in a typical recommendation system is it's again a machine learning application. It takes huge amount of data, several hundreds and thousands of users, their interest. It can be movies, it can be songs, it could be products, it can be mobiles, it can be food items, okay, it can be visiting restaurants. They all rank these things. It is represented as in a matrix, okay, row column. User says rows, column says items, okay, they rank. By taking that, when you rank, there is what is called some features, okay. When you rank this thing, you talk about who is the director of the movie, whether it is a thriller or a comedy, okay, or romance, or what type of movie it is, okay. That, based on that, you rank this thing. So there is another matrix which is latently representing that. It is a matrix decomposition problem using learning algorithms techniques. It calculates certain things and it recommends people, those who have not bought a product, not listened to a song, not watched a movie, that you better do that. Okay. And this is an interesting problem involving matrix decomposition, computation, and all. Systems, ranking, and personalization of content. Like Google ranks its pages, page ranking. It's again some computation intense database problem because there are hundreds and thousands of pages. Depending on who is visiting and how many from that node it is going, graph representation, they do that. Applications of AI in COVID-19 pandemic. Why I gave that? As I said, machine learning, particularly a branch of AI, machine learning is useful for prediction, for classification, for detection, and all these things. Early detection and diagnosis of the infection. AI is helpful in the diagnosis of the infected cases with the help of medical imaging technologies like CT, computer tomography, magnetic resonance imaging, scan of the human body parts. In fact, these images are taking based on transparent parts, opaque parts, the doctor sees that. You give that image to a machine learning algorithm, it said, look, such and such to the pattern of the data, the machine learns, give it to a supervised training algorithm, train it. You say if this is the pattern, this is a mild symptom. If this is the pattern, it is severe. And this is the pattern, the patient needs ventilator. Okay? So this can be done automatically. In fact, CT and MRI is an expensive proposition. These days, people are using X-rays. X-ray is a cheap method. X-ray is available in most hospitals. It is not very expensive to take an X-ray, but whereas CT and MRI are very expensive. So these can be used for detection, diagnosis of the patient. How? By looking at the images, extracting the features. You train this one. Okay. Monitoring the treatment. A neural network can be developed to extract the visual features of this disease, and this should help in proper monitoring and treatment of the affected individuals, whether they are progressing. Okay, because When you talk about learning and training, what happens? We get data from different countries in the world about the disease, gender, male, female, comorbidity cases. There are heart patients, there are cancer patients, there are aged patients, male, female, and all that thing. There are different conjectures. You store this data. Okay, the machine learns. Okay, from that, next time when it comes up with something, it takes a decision rather than the doctor or nurse attending to each and every patient, which is impossible. In fact, machine learning algorithms are used for vaccine development also by looking at the protein structure and all the previous viruses and all that thing, how to come up with that. Contact tracing of the individuals. AI can help analyze the level of infection by this virus, identifying the clusters and hotspots, and can successfully do the contact tracing of the individuals and also to monitor them. It can predict the future course of this disease and likely reappearance. Predicting the risk of infection, age, pre-existing condition, general hygiene habits, social habits, number of human interactions, frequency of interaction, location and climate, socioeconomic status, culture. You get huge amount of data. What happens in China is not valid. What happens in India may not be true in Europe. Okay. How do you do this study? You get huge amount of data available. Okay. One is doing some forecasting. Second is storing the previous data and what type of treatment has really worked and what type of patients next patient gets. How do you take this decision? At least an immediate conclusion by looking at the X-ray, looking at the image, and looking at some of the test results. Can you immediately come to a conclusion and say whether it is a mild, little bit serious or severe, whether the patient needs admission, needs ventilator, if ventilator, for how many days, what setting, how the ventilator settings have to be controlled. There's so many things. Identifying who is most risk, infection risk, severity risk, outcome risk, you can classify because already you have past data. From that, you can say such and such, such and such, for this one, the machine is trained, you will say this is a high risk, this one. Once you get the this one. Screening patients and diagnosing, like face scans, fever, smartwatches, heart rate, machine learning powered chatbots to screen patients based on self reported symptoms. Okay. Chatbots can be used, and the chatbots can be used even to train doctors, nurses. Okay. Robots can be there equipped with AI machine learning to handle the sort of disposable items in the COVID care centers, okay, where it is very dangerous to handle some of these things and transport items, many things, reducing the workload of healthcare workers so that if it is automated, machine learning algorithm, computer does that, the doctors and nurses can spend time effectively and the stress on them can be cut off. Projection of cases and mortality. It can track and forecast the nature of the virus from the available data, social media platform about the risk. Because your machine learning algorithms, supervised algorithms, when you talk about regression, okay, in a regression, it is nothing like something like a forecasting you talk about. In a regression, you can talk about some amount of, you can train the neural network to predict, okay, about, then it can predict about the risks of infection, its likely spread by looking at the data from other places and all the machine can be trained. It can predict the number of positive cases and deaths in any region. AI can help identify the most vulnerable regions, people, and countries and take measures. Development of drugs and vaccines. This technology is used in speeding up drug testing in real time, where testing takes plenty of time and hence helps to accelerate this process significantly, which may not be possible by a human. One can do through other methods, simulation, and all other techniques and all. And vaccine development also needs some machine learning techniques. I will just spend a few seconds. We have been talking about cellular networks, and all that. How is machine learning useful in cellular networks? Learning based dynamic frequency and bandwidth allocation methods yield significant performance in cellular networks when the system learns that. Artificial neural networks solve propagation loss estimation with input parameters selected from transmitter, receiver, buildings, frequency, etc. In 5G, we talk about MIMO, multiple input, multiple output antenna systems, several of them working in parallel. Machine learning is used in MIMO technology for channel estimation, direction of arrival estimation using deep neural networks. Okay, deep neural networks with a number of layers. We will talk about that after a while. Machine learning can develop accurate path loss models based on publicly available data sets. Okay. So when we talk about machine learning, what are the types? We have what is called a supervised learning, would like to do prediction, estimate the function f of x so that y is fx. We talked about prediction of disease, okay, like COVID and all that. What happens that you do want to predict, okay, estimate the function f of x so that by x you get some data x, okay. I want to fit it with a function, okay. I want to come with f of x. Y is f of x. The neural network can do that. Machine learning algorithms can do that. Okay. So this can do, but such a thing can be used for prediction. What happens in future? Okay. If x is such that time, I get this the y, the rate and such time. Okay. What happens after a few days? What will be the death rate? What will be the infection rate? Okay. Huh? And what will be the recovery rate? One can do that. Where y can be a real number, it is called regression. If it is a real number, okay, which is called curve fitting or prediction. If it is a categorical classification, what do you mean by categorical classification? You give features. Like if it is a facial recognition, you give it to the neural network in a supervised network. If this is the position of the eye, this is the color of the hair, these are the placement of the cheeks, this is the type of the lips have, this is how the nose looks like, and this is it, and this is such and such person. Classification. It can be used for fingerprint classification. It can be used for healthcare, medical classifications. If it is any particular disease, for example, if it is an MRI, CT, PET scan, you take. If it is a image you take, for example, you take the brain image, there is a tumor. You want to find out whether the tumor is carcinogenic or not, whether it's cancerous or not. It has some features. The doctor knows from that. You train it to that. If this is the feature size, it tends to be carcinogenic. So it can be used for classification. Okay. Complex object, ranking of items, parse tree and all. What we do, it has to rank into different things. Data will be labeled that have many pairs x, y. That x is a vector of binary you give categorical real valued features. Y is class. It can be +1, -1, or a real number. Okay. X are the inputs. You give the features. Y, it will say it is a specific class. Okay. For example, when you say fingerprint, if you take there are what are called ridges, strokes, and all that thing. If this is the type of fingerprint, if I get it, he's a criminal, such and such person. Okay. And who is the criminal also can be identified. So what happens in a training set in a supervised method? You see, estimate y as f of x on x and y. Okay. And hope that the same f of x also works on unseen. Unseen means what? There are two things. One is training, another is testing. First, we train in a supervised method. You give some known features, known x's, and we know y. There is what is called data and label. Data is x, label is the output y. You know that. If this is the x, this is y. Okay? Or if it is x1, y1, x2, y2, x3, y3, we know that. But there is an unknown x given. You want to know what is y. This is what is called your testing or prediction. If you get, you have a training set and a test set. Okay, so it works on the unseen also. It should work. This is what is called supervised training. Okay, where there is a learning. Okay, you train it, and once it is learned, you test it with unseen sample. But people say biologically, it is not plausible that everything is trained this one. What is conjectured is human brain has 10 power 10 or 10 power 12 neurons. Each neuron inside there is electrochemical pulses like sodium, iron, potassium, consisting of these things. So when the pulse is transmit, when the pulse fires, there is some sort of competition taking place. There is some change in ionic concentration and all that. And each neuron is connected to 10 to the 4 of the order of 10 power 4 of its neighbors. So the number of connections at 10 power 12 and 10 power 4 at 10 power 16, when you stretch, it will run to several hundreds of kilometers. Okay. So it's a massively parallel distributed system sitting inside our brain, the spongy mass, okay, what you find there. So when you look at its properties, as I said, it is highly fault tolerant. Neurons die, but you still keep functioning. And its fan out is so high. No electronic system has this type of fan out. It consumes least amount of energy. Doesn't have to be programmed in C, Fortran, Pascal, and all that thing. But one of the important things is what people say. It is it is not biologically plausible that we all are under supervised training mode. Who tells the child a few days or few weeks how to recognize the voice of dad, voice of mom, face of granny? Nobody teaches. The child automatically, by looking at that, can't even speak, looks at those things, extract the features, and somehow other learns. Okay. So what we say, the biological plausibility is probably unsupervised learning. There is no supervision. Nobody trains and teaches if this is the input, this is the output, this is the input, this is the output, and do that. Okay. So in unsupervised learning, a data set x1, x2, xn is given, xi belongs to x, defines a model of the data. The goal is learn the structure within the data set as defined by the model. With supervised learning, we have a clear measure of performance, prediction accuracy. With unsupervised learning, things are often more subjective. It clusters or groups the data into some clusters and groups. There is nothing like a training here. Okay, like this is the input, this is the output, and do that thing. Okay, it is a the clustering model. Seek to partition the data x1, x2, xn into groups like image segmentation, data quantization, pre-processing. This is also used in matrix factorization. Learn an underlying dot product. We'll talk about this later. Okay. So in a clustering, what happens? As you can see, the problem is given some data x1, x2, xn. Assumption is each data point belongs to exactly one group called a cluster. There are groups or clusters. Okay. Goal is to partition the data into groups such that observations within a group are similar and observations in different groups are dissimilar. That's what we do given data, isn't it? We want to cluster a group that this set of data belongs to this set of data belongs to this. Cluster alignment, assignment, representation. So what we do, we have to divide into what are called K clusters given the data. So clustering, and what is the typical thing of what is called k-means. K-means is the simplest and most fundamental clustering algorithm. Given input x1, x2, xn, x belongs to uh, d-dimensional real for now. Output is cluster assignment vector C and the k-mean vectors mu. So you have what are the C1, C2, C3, Cn? These are called the cluster assignment vectors. So Ci belongs to this particular cluster. Mu is what is called the centroid, which defines a cluster. So what we do, it is very simple. This is how the algorithm looks at. Listen, given this cluster of data, initially, all this data, initially you randomly uh, cluster the data, randomly. And how many groups K? Choose K randomly. Okay. Choose K randomly, cluster these things. Okay. Once you cluster the data, this is one group, another group. So for each group, you calculate its centroid. Okay. Right? You know how to calculate centroid geometrically given the distances. Okay. Once you calculate the centroid of that, then find out the distance of the, you have a large number of points, you have given the centroids given. Okay. Now you calculate the distance of each of these points from these centroids. Once you calculate, you will know the one closer to the centroids. If they are far off, you have to push closer to the centroid. That means they have belonged to a wrong group. You understand that? You push closer to them, so the data moves, so they get shuffled after one iteration. Once the data are shuffled, they come closer to this point. You again calculate the centroid, right? Once you get a new centroid, new grouping, now what you do? You repeat the process. Again, calculate the distance of all these points from the centroids, find out whichever is not close enough, pull them to nearest to this point. You iteratively do this process till such time there is no further change in the centroid and no further movement of the points. That is when it converges. So we have essentially clustered or grouped this. Each mu defines a cluster. This set of I for which CISK indicates Xi are clustered together. As usual, we need to define an objective function. Tell us what are good C and mu that we can easily optimize. So this is what it happens. As you can see, K-means algorithm. Initially, you started with a random initialization. Iteration 1, they group like this, assign data to the clusters. Then iteration 2, update the centroid. The centroid have moved, that cross marks what you find. Then iteration 2, assign data to clusters. Okay, and again keep repeating that, calculate again the distances, keep moving those things. We have what are called finding similar items at distance measures. Goal is find near neighbors in a high dimensional space. We normally define near neighbors as points that are small distance. Okay, they're bringing closer to together. So we use what are called Jacquard distance for similarity. The Jacquard similarity of two sets is the size of the intersection divided by the size of their union. Okay. Similarity C1, C2, Jacquard similarity is defined by C1 intersection C2 divided by C1 union C2. What is Jacquard distance? 1 minus that is Jacquard distance. You see, there is an example. There are two sets given. What is intersection? How many are there? 3. What is the union total? 8. So what is Jacquard similarity? 3 intersection divided by union 8. Jacquard distance is 1 minus 3 by 8. That is 5 by 8. These are used in some of these similarity computations. Given a large number, and in the order of billions or billions of documents, find the near duplicate pairs. And again, examples of some large data, big data type of application. Applications are mirroring websites or approximate mirrors. Don't want to show both in search results because there are when you are searching through the websites, there are mirror websites, okay, or there are approximate mirrors. So you should not waste time unnecessarily searching those things. You should avoid, remove them. Okay. Similar news articles at many news articles, cluster articles by same story. Okay, when you are searching or grouping them and looking at that. Okay, many small pieces of one document can appear out of order in another. Too many documents to compare, so documents are large, so they cannot fit in the main memory. You need some big data type of approach. So what we need in this thing, there are 3 essential steps. We convert the documents to what are called sets, convert large sets to short signatures while preserving the similarity, okay, by using similarity preservation algorithm. Then focus on pairs of signatures likely to form similar documents. Like we go through what is the first the set of strings of length k appear in the document. You get shorter vectors than those pairs of signatures that we need to test for similarity. This is all a brief about that. I'll quickly switch gears and get into what is AI. Okay, because machine learning is said is one part of that. AI was the word was coined by Professor John McCarthy in the year 1956 in the Dartmouth College. They had a small conference. a group of about 10, 12 people. He is called the father of AI. He defined it as artificial intelligence is the science and engineering of making intelligent machines, especially intelligent computer programs. Looks like a simple definition, but it's quite tough. Because if I now go around and ask all the attendees, define what is intelligence, natural intelligence, what is intelligent, I will have at least one definition from each of you. The number of definitions minimum will be equal to the number of people attending the seminar. Okay. So natural intelligence, artificial intelligence, consciousness are very tough things to define. There are many definitions. Famous mathematician Bellman said the automation of activities that we associated with human thinking, activities such as decision making, problem solving, learning. These are our main features: decision making, problem solving, learning. The exciting new effort to make computers think machines with minds. The study of computations that make it possible to perceive, reason, and act. The study of mental faculties through the use of computational models. In AI, we get different terms. We get what is called weak AI, strong AI. What is weak AI? Like diagnosing a disease, what the doctor does, if the AI doctor is that. Playing a game of chess, what Gary Kasparov did against the IBM Blue machine. Okay, so the IBM Blue has beaten the world chess champion. Similarly, you have Dota game, Go game, many games. Best of the world champions have been beaten. In Jeopardy game, the machine has won. So these are what are called weak AI. It can do only specific domain. But what is strong AI or general purpose AI? Like having a general intelligence to do something. Weak AI is very weak in a specific domain doing something, limited operations and abilities. But whereas in a strong, it is general purpose with a lot of abilities. That is where we talk about artificial narrow intelligence in one specific domain. Like we said, playing the game of chess, playing the game of Go, playing the game of Dota, and all that thing, or diagnosing a disease. Artificial general intelligence is like we human beings do. We can play a game, we can write a poem, we can conduct research, right? We can teach a course. There are different things which can be done by human beings. There is a problem in AI now which is being discussed called singularity or superintelligence. If the hardware and software advances take place like this, new algorithms come up like this, so with time there is a scare that these machines will be as intelligent as human beings. A day will come, they will take over us. Okay, these are called super intelligent machines. They will take over human beings. There is a scare that the robots will not listen to us. They will go on strike, and there will be problems. What happens? Okay, so this is the famous problem of singularity. The do we have that? But there are different schools of thought. People say it won't happen so soon, it will take several years. How can it happen? We computer scientists develop algorithms, software, hardware, code, and all that thing, how the machine automatically will do. But still, recently we have seen Facebook, there are two chatbots engaged in some conversation which nobody could find out. So these are different aspects outside the scope of this talk. So, what an AI system does? It learns from experience like us, uses the learning to reason like we do, recognizes images, solves complex problems, understands languages, its nuances, which is again very difficult, natural language problem, okay, and what is sarcasm, what is joke, and all that thing, and creates perspectives about scenarios, environment, and all. That is what human beings have, and then AI system should be able to do that. One of the important components is uses the learning to reason. That is where we talk about learning algorithms and all. But other than that, there are a large number of other issues when you talk about knowledge. How do you represent the knowledge using logic, first order logic, propositional calculus? Okay, how do you store the knowledge in the form of production rules, in the form of semantic network, in the form of frames? There are a lot of things. So AI is not machine learning alone. It is one small part of it. There are a lot of things in AI. It has applications like natural language processing. Then you talk about syntax, semantics, how do you do? There are ambiguities in language. Okay, we human beings understand that there is a common sense, okay, which uh, we possess can handle that generalized problems. There are many issues. So traditional machine learning, you see, it can very simple decision tree for determining, like based on age, gender, occupation. Like if you say if age is less than 15, it's a male, do something, otherwise no. It goes through a simple decision tree. Program consists set of rules. They have there are many problems. What you find in the left side, there is a handwritten character digit recognition. You cannot do it manually, it is very difficult. That is where you want a machine to do. You have to extract the features, set up rules are very difficult to do by hand. You have what are called the CIFAR 10 database of images. You have aeroplanes, automobiles, birds, cat, deer, dog, frog, horse, ship, truck, and all those things. Set of rules. So the set of rules is impossible to design by hand. Okay. Machine learning with big data. Why do machine learning on big data? The volume of data is too large for comprehensive analysis, and the range of potential correlations and relations between disparate data sources, from back-end customer database to live web-based this one. That is where huge amount of data is there. So one has to save a big data and classify from these things. So learning is everywhere. As you can see, image classification, speech recognition, language translation, language processing, sentiment analysis. Like if today robots are used for healthcare applications, elderly care, they should be happy, they should pat people. And from the facial expression, one should be able to know whether the robot is happy or not. Similarly, the robot also should be able to know whether the patient is sorry or happy. This is now used in shops, in merchandise application, to see whether people are happy about a product or not. How? You put a camera in a shop, if you shrug your shoulder, you use your lips, you use your eyebrows, you use your cheeks. From that, you can find out whether the person is happy about the product or sorry about the product or not quite happy. It is used for commercial feedback rather than taking from the net. There is one area of computing called affective computing, AFFECTIV. So this is like emotional or sentiment analysis. There is a different area of research altogether using AI machine learning techniques, taking these image features and all. It can be used in medicine and biology, as I said, cancer cell detection, diabetic grading, drug discovery, then video captioning, video search, security applications, facial recognitions, autonomous machines, pedestrian detections. Suppose it's a driverless car, if you're talking about pedestrian detection, lane tracking, recognizing traffic sign, and all that stuff. Okay. For example, today you see if you walk into a hotel, every time you are nervous whether you will leave the key inside the hotel and latch yourself out. So what is done best is when you check in at the reception counter, they take your image. When you stand in front of your door, there is a minuscule camera which takes your facial features. From that, using best of the facial recognition algorithm, machine learning algorithm, SVM, and all that thing, it will classify and say this person is permitted to get in. A mini robot will open the door there automatically using best of the machine learning algorithms. And to do it in real time, you have DSP cards, DSP boards to do all the signal processing. Okay. So in machine learning, the basics, as I said, there is a learning algorithm. It takes data. It's a training set. First, you train it. Okay. You say this is a feature. This is the object. Okay. Next, what you do, prediction or classification. You test new unknown thing. You give it to the learning algorithm. If it is correct, you say right. If it is wrong, it is wrong. Okay. So what you do that in this case is you find out what is the percentage accuracy of the classification. Okay. So there are what are called supervised learning, learning with a label training set. Without our knowledge, every day when you use our emails, there is an email spam detector. Automatically detects the spam. It filters. We don't know that. Whether many are filtered. How? By based on the features. Okay. If you have got a mail telling that several millions of dollars you have won, it comes from some African country or somewhere unknown place, and it promises something great. and you know that it might be a spam. It is diverted to spam. Unsupervised learning, discovering patterns in unlabeled data, like as I said, clustering or grouping them. Okay, that is unsupervised. That is clustering or grouping. Reinforced learning, learning based on feedback or reward. Like how do you play the game of chess? If you win, lose. If you win, lose. If you win, you are rewarded. If you lose, you are penalized. Okay, that's what happens. What happens in artificial neural networks, as you can see, a collection of simple trainable mathematical unit that is collectively learn complex functions. Okay, given sufficient training data, an artificial neural network can approximate very complex functions, as you said, neurons inside. There will be an input layer, there is an output layer, there are some hidden layers inside. So in the input layer, you give the features, and output layer, it will classify whether this is such and such object, such and such face, and all that thing. Okay. Artificial neural network. Okay. As I said, there is a biological element like a neuron. A simple neural network is shown in the figure. There are four input units and one output unit, as you can see. X1, X2, X3, X4, etc. are inputs, and there is an output. If this is the input feature, this is the output. Okay. So the inputs are weighed by water weights. You find there is a function of W transpose X. X1 is multiplied by W1, X2 is multiplied by W2, X3 is multiplied by W3, and there is a B bias vector added, and if it exceeds a threshold, it fires. We get a simple representation of the neural networks. As you can see, this is the output. Okay, different inputs, weights, and all that thing. Hmm. And if the same thing, it goes through at the output level in an activation function. Okay. In a network, neural network, we have different layers, inputs, layer 1, layer 2, layer 3, and there is an output which gets this. In a typical back propagation, we talk about input layer, number of hidden layers, and one output layer. We have been hearing recently deep learning. Deep learning is a sort of a multi-layered simple architecture. In 1962, Hubel and Wiesel were looking at the cat's visual cortex. They find that when light falls on the retina of the cat, it passes through what is called LGN, V1, V2, lock, and different layers. Similarly, they say when we look at an object, we don't see at a stretch. Inside our brain, it goes through after the retina. In one layer, it sees points, next layer lines, next layer curves, next layer forms the edges, then surfaces, things like that. So it is a different layers you find. Each layer is responsible for something. As you can see, I have shown A there. There is a left stroke, there is a right stroke, there is an inclined line. In one layer, the left stroke is detected, another right, another the inclined line detected. That is what you find. And the filters or the kernels are responsible for detecting each of these layers. Okay. We have input layer, different hidden layers like back propagation you find. Number three, as you see a character, there is what is called a top stroke, middle stroke, bottom stroke. There is a curve joining them. It goes through different layers. It can have supervised and unsupervised level. Please note that in a convolution neural network, it is called convolution neural network because the filters do some convolution operation there. We, if it is unsupervised, we need not have any, there is no question of giving any features here. You don't have to extract any feature. Deep neural networks are good for object recognition, speech recognition, image recognition. Give the data straight away. You do not have to give any features, do not have to extract any features like traditional neural network method. It automatically selects the features by through this setting the different coefficients and different filters and different layers, detects that at the last layer there is what is called a backprop layer, fully connected layer. And because we are talking in a discrete domain, in a discrete domain, the convolution is nothing but product and summation. continuous domain, it is integration. So you have convolution stage, it is sigma KL, WKL, Z I minus K, J minus L. Then we have a nonlinear stage. In a pooling stage, you take only few of these sort of pixel levels, areas, because you want to cut down on the computation load instead of doing so much of computation. So it goes through what is a convolution stage, pooling stage, number of stages. I have shown three different colors there because we talk about RGB color. For each color, we have a pair. Different algorithms are that typically in learning. We have clustering, you want to find out associations. By association, I mean you want to find out to get some clause. Suppose someone has gone to some shopping mall to buy milk and sugar. There is a high probability that he or she will buy coffee also. Okay. So there is some association learning, parameter estimation, recommendation engines. I gave an example, classification, and all that thing. Okay. Clustering, this is how it works. I gave you examples of clustering that into different things, iteratively proceed. Machine learning can be used in human activity like walking, running, gait. It's used in natural language processing, computer vision. Okay. And the machine learning package, what you find in big data, as I told you, is Mahout. It supports large number of these packages, starting from support work to machines, K means classification, number of them. There is a page ranking algorithm. I'll skip that. We don't have time. Okay. There is what we call product recommendation. When we have related product recommendation, like in Flipkart, okay, movie recommendation, Netflix, Facebook. I told you, I gave you an examples of Kannada movies, Hindi movies, songs, when somebody has to recommend these things, how it happens. I have a video, quickly, let's hope it plays. I don't know, let me see. ಎಲ್ಲ ಕ್ಲಿಯರ್ ಆಗಿದೆಯಲ್ವಾ ಸ್ಟಾಪ್ ಇನ್ ಅಬೌಟ್ 10 minutes. ಓಕೆ ವಿಡಿಯೋ ಕ್ಲಿಯರ್ ಆಗಿದೆಯಲ್ವಾ So this is, hello, this is what is used, as I said, for there is a technique called collaborative filtering, okay, where one can use the video essentially showed you how Amazon is using for recommendation systems, okay, for products, okay. So recommending products, recommending movies, recommending new types of goods that is used. This involves machine learning, and there is a technique called collaborative filtering. Basically, you have got some items. These can be movies, books, beers, whatsoever it may be. You scale them in 1 to 5, 1 to 10, and can you use these recommended items to a user based on their ratings? If you use the correction between their ratings and other people's ratings, it is called collaborative fitting. You take others' rating, your rating, interesting. There are many approaches possible. I will not get into maths of this thing. It is a simple matrix factorization problem. There is a V is W into H. So V is nothing but is a matrix, rows or number of users, columns are like say movies or mobiles, okay, or the songs. People rank these things. As I gave you examples of Hindi movie or Kannada movie, you can rank that. Some movies you have not observed, your friends might not have observed. They are observing based on the similarity of the interest. Okay, they collaborate. Okay, on this, it is suggested to them how whether you might be interested in watching that particular thing if you have not watched that or if you have not bought that product. Okay. So what happens here, given an M by matrix V and a latent factor R, latent factor R is that is what I said. You have number of users or viewers, columns or movies say. What are the latent factor? When you appreciate a movie, it is based on the director or the type of action, or the type of the script, some of these things. So this the column belongs to that the factors. Multiplied by another matrix will be there. Again, those factors and the movie, which one. So based on that, essentially this choice takes place. We have what is called V is W into H. W is the feature matrix. It has a rows for each feature, column for each column, and is the weights. We try to essentially do this matrix factorization. That is, V is given to you. That is, V is number of rows and number of products, their rankings. You have to split into two matrices, W into H. Okay, and this is done by the actual value Vij is known. You are starting with a random choice of WH. Okay, Ij columns. You take the minimum sum of the squares of errors, minimize that, and get the elements of V. So what you have is movie rating, set of users, set of items like movies, books, jokes, product stories. Feedback is ratings, purchase, click-throughs. You can see at the bottom you have Alice, Bob, Charlie, etc. Movies are Avatar, Matrix up. This could be our Kannada, like Bengaluru Malay, or as I said, the Hindi movie, your Three Idiots and all. And question mark is they have not been given any score. You don't know. So based on others' interest, your own interest, so it tries to essentially do this splitting calculation, enters these entries, and recommends you what is the rank. It goes through the calculation, finally fills the elements, and tells you from that whether you may be interested or not. Going through the decomposition process, it pushes the final missing entries there. Okay, these are maths. I talked to you about the programming language R, which was developed by social science professors for graphics, then database, scientific computation. It is flexible, extensible, comprehensive for productivity. Okay, it has very good facilities for getting summary sheet functions to make descriptive statistics, and you can get linear regression. It's again a free package. One can do that. Then visualization, what are called fan plots, you can get number of interesting things like box plots, virtualization plots, and all. Deep learning in big data analytics, these extract meaningful abstract representations from raw data through the use of an hierarchical multi-level this one. This deals with data abstraction, represents likely suited analyzing raw data. So deep learning in big data, you say dimensionality. Okay. So we have other techniques. I didn't have time to get into that. Principal component analysis, okay, independent component analysis for dimensionality reduction and all that thing. There are a number of these methods. So IoT needs big data, as I told you last time. Things means Raspberry Pi Arduino and all. Devices are sensors. They measure temperature, air quality and all. Devices give rise to big data, to the analysis, to the devices give you the data, then you use some big data analysis to that, then insights using learning algorithms. To conclude, the amount of data continues to increase at an exponential rate, but the improvement in the processing mechanisms is relatively slow. Despite the plethora of work performed to address the problem of storing and processing the big data, certain important aspects of storing and processing big data in cloud is yet to be solved. And these opportunities, exploiting the opportunities that big data presents, requires new data architectures, new analytics sandboxes, new ways of working, and new applications and development of new algorithms. For example, right now there is a new algorithm other than deep learning which is coming called generative adversarial neural networks, or GANs, generative adversarial networks. There are two networks, each trying to cheat the other one. Okay, and finally they sort of come to a conclusion, and these are used in producing fake images, fake videos, fake tests and all, which is now a challenging problem now. In fact, AI has been used to generate these fake media, fake news, fake videos, and it is also used to detect those things, to detect fake news, fake videos and all that, right? So there are a lot of challenging aspects you find here. The challenges are primarily, as you can see, one of applications, developing new learning algorithms, and understanding these. For example, even now, people have not fully understood why deep learning works. Okay, we have different layers, it does that, why it works. Uh, we try to link all those things, big data, that is the sources is through sensors, then Facebook, Twitter, and all that thing, cameras. Then using this data, using big data platforms, Hadoop, and I told you Spark, and number of database packages, analyze those things, and to get to some conclusions. Machine learning algorithms using deep learning, GANs, neural networks algorithms, supervised, unsupervised, reinforced learning, and there are what are called semi-supervised algorithm, mix of supervised, unsupervised. Some for this you take data label, some this unsupervised algorithms. Okay, thank you. Any questions?
Thank you, sir.
Professor Ravi.
Uh, yes, sir. Thank you, sir, for giving us valuable insights on big data methodologies and technologies. Sir emphasized on big data challenges, different classifications of big data, platform for big data analysis, MapReduce, machine learning algorithms, and the impact of AI and COVID-19 treatment, collaborative filtering, and data analytics. We got some queries, sir.
Yeah.
So the first one is, can we use machine learning and AI in EEG for analysis purpose?
Yes, it can be used. If you look at a typical EEG signal, it has, you know, that alpha, beta, delta, different waveforms, different frequencies, low frequency to high frequency. The doctor looks at that and finds out whether any disorders, whether it is ECGD or EEG, after all, it is a waveform. Okay. What the doctor does by looking at that same thing can be trained to machine learning algorithms and use that. In fact, uh, we ourselves have done that. My students have worked. We have published some papers in computer programs in biomedicine using SVM and some other types of machine learning algorithms. Okay, and found out reasonably good results. It is possible to use machine learning algorithm, like you can use support vectors, you can use SOMs, you can use supervised, unsupervised learning algorithms, and you have to extract the features and give it if it is supervised, like what the doctor does.
Thank you, sir. There is one more query, sir. How
Yeah,
can we make use of big data in cybersecurity?
yeah. See, in the big data can be useful in cybersecurity when you talk about attacks and all these things. One of the things is there is a pattern when you talk about an attack. In fact, you can use machine learning and big data combined. When hackers hack and do that, they do from different platforms. There is a pattern over the months and years and all. One can store this data. Okay, what happens on different cyber attacks, either on the websites or on the machines, and from that, the machine has to learn, find out a pattern, give this thing. It's automatically do that, so that next time when there is an attack, it tries to alert, or see, when tries to do that today, tomorrow, number of days, it tries to alert that. Because in all these things, there is a sort of built-in pattern that the machine has to be trained to extract that. You say, if this is the time, if this is from where it is originating, if these are the addresses, this is an attack. The machine can be trained if it is supervised. If it is unsupervised, you can simply cluster and group. And if these are the patterns, this is an attack. You can do that.
Yes, sir. Thank you, sir. There is one more query, sir. Which are the factors that affects the performance of the machine learning system?
Which are the factors? One
Yes,
of the
sir.
factors, one of the factors is accuracy. We gave examples of COVID detection. We gave examples of EEG detection. Once you train it, yes, it does that. When you test it, okay. So there is what is called at training stage accuracy, at testing stage accuracy. Okay, and accuracy is important thing. Like in how many cases it gave correct results, what is the total things it you tested. That is one. Second thing is we call false positive, false negative, specificity, sensitivity. These are the parameters. False positive means sometimes you give the patterns and data and all. You should it should not come up with a positive disidentified. It by mistake it gives that, then it is a false positive. So how many false positive are there? How many false negatives are there? There are two more parameters called specificity and sensitivity. We look at four parameters, then we talk about accuracy. So you essentially look at these performance parameters. Other than, of course, execution time, which nobody is worried these days. Okay. Most important is the accuracy. Even though, for example, it may be 99.99% accuracy, in some cases, even a small inaccuracy, if it is a healthcare system, medical system, it may be dangerous. Or, for example, if it is a case of giving loans based on women and black, it tries to be getting biased. Most of the machine learning algorithms have problems of bias and all that thing. If the data is biased, the learning algorithm is biased, it takes biased decision. Okay, so you have to classify and find that also.
Thank you, sir. And the last one is, sir, what is the significant impact of big data on food processing industries?
Yeah, in case of food processing industry, again, of course, we are talking about IoT being used in food processing industry. For example, sustainability. We have so many godowns, let us say. Okay, we talk about temperature, humidity, conditions in all these things across the country. One thing is you can talk about the inventory, okay, where you have what type of food, fruits, vegetables, which state, which city, where you have, what is the price, how you can transport, what is scarce somewhere, okay, what is seasonal, what is not seasonal. In a big data environment, one can put that. Another is the condition. There are sensors, give all these things, right? Essentially towards what we call sustainable food development, right? Sustainable food production, one can talk about. There are so many of these cold storages, storage places of food, fruits, vegetables we store, right? Their condition, transportation from one place to another. It will help in supply chain. It will come in the loop network, transferring from a place to place. Where there is surplus, where there is shortage, right?
Thank you, sir.
Yes.
We got good feedback from the participants, sir.
Thank you.
Like very nice session, good
Okay.
session,
Okay.
very informative session
How many
from
were
the
attending?
participants.
How many were attending?
More than 100 students, participants were there, sir.
How many?
100, sir.
Okay. Thank you.
Ah, sir. Oh,
I hope it was clear, right?
yeah, yes. Yes, sir. Yes, sir. It's clear, sir.
You can visit my website, get my Gmail address. Any queries, you can send it further details.
Sure, sir. Sure, sir. We will do it, sir.
Thank you.
Thank you, sir. On behalf of management, principal, and from the head of the Department of Electronics and Communication Engineering, we would like to thank once again Patnaik, sir, for accepting our invitation and gracing these events. Thank you, sir.
Thank you.
And dear participant, let's break for the session, and we will rejoin in the afternoon for the day 1 session 2, which will be handled by Mr. Mahavir Penna, Assistant Professor, Department of INSA, SVC Bengaluru at 2 p.m. sharply. Thank you.